As we continue to look at hyperbolas that are centered at the origin, now we're looking at exercises 17 through 24, where we have to find this standard form given our vertices or foci. So these are centered at the origin. As you can see, the foci is plus or minus the same number with the 0, and the vertices are also plus or minus the same number. So I can see that's centered at the origin, but let's draw it first to see. Okay, so first thing I do is plot the points. I like to get a visual, so it doesn't say to graph it. I'd always sketch a little graph because for helps my brain organize the information. So the first thing I'm going to do is plot my vertices. So I'm given -1, 0, and +1, 0. And then my foci, -3, 0, and +3, 0. So remember, this is my C and this is my A. And I can see then the center is going to be halfway between the two foci, or halfway between the vertices. So my center here is at the origin. So I know I'm going to fit one of these two equations. And I can see it's going to open right and left because my foci and my vertices are on the x-axis. They're in the horizontal direction. So I'm looking at this. This equation and this graph, these definitions for A and B. And I have, okay, so I'm looking for that equation. So the general form of that equation, actually, I'll just make a note. Okay, so I'm noting a couple things. Opens right, left instead of up, down, which tells me, and it's centered at 0, 0. And those things together tell me that I'm using this formula. So I really just need the A and the B to define that formula. And I can see A right here. A is defined by the foci. I'm sorry, the vertice. So A is 1. And I don't have B, but I have C, right? C I can find from the focus. So C is 3. So to get B, we use this relationship. So I have the relationship C squared equals A squared plus B squared. So to solve for B squared, I subtract A squared from both sides. So I get B squared equals C squared minus A squared, which is 3 squared minus 1 squared, which is 9 minus 1, or 8. So now I have B squared. And I don't really need to solve for B because the thing I'm going to put into the formula is actually B squared. So I'm even going to identify A. I'll use A squared, which is 1. So then plugging those into the formula, I get x squared over A squared, which is 1, minus y squared over B squared, which is 8, equals 1. And I can take this one step further because I don't need that 1 in the denominator for the x, so I'll just write x squared minus y squared over 8 equals 1. And there is part C of 8.4.1. So you're doing 17 and 19 from this section.